Hello friends, and in this lecture we are going to discuss the computer science subject is called as ATC, and ATC stands for Automata Theory and Computations. 1 minute. ATC, Automata Theory and Computations. So what is automata is? Automata is just like an abstract machine. Yeah, you can consider as a machine in the simple language. This is just like a machine, and how to design what this machine can do. We'll study this full theory and few computations, how to design, what are the requirement, and what are the useful of these machines. We'll study in this subject. And computations means like a mathematical model. Mathematical model. What is mathematical model is? This is the like a machines only. We are designing the machines in this lecture, in this course. What type of machine is? There are two type of machines: finite state machine and NFSM. This is called as FSM, finite state machine. Finite state machine. Another is called as non-finite, non-deterministic, non-finite state machine. So what is the finite state machine is? Which is converting infinite input. Like consider something I am telling to you, design the machine which can accept any number of A's. Yeah, even number of A's. So even number of A means maybe you can give 2 A's, 4 A's, 6 A's, and up to the 1000 A's, 2000, 1 crore, whatever. This is the infinite input. This is infinite input. We are converting to the finite input to accept it. That is called as finite state machine. So here in this, before starting this course, I'll give you the basic notation using in this course. This is the basic notations. Consider if given what is alphabet. Alphabets. Alphabet is nothing a finite set of symbols. This is the finite set of symbols. Yeah, symbols you also can represent in this course as a input. Input represented as a sigma. Input may be your 0, 1, 2 up to the 9. Yeah, A, B, C, anything up to the small z, yeah, capital A, B, C, anything. This is all is your input. Yeah, also called as alphabet. Another is called as string. What is a string? A string is over the alphabet. Yeah, set of alphabet is called as set of alphabets are called string. String. Like anything, consider 3 A's. This machine is accepting 3 A's. Then you can add 3A. This is your string only. Yeah, if any machine is accepting even number of A's, so 2 A's, 4 A's, 6 A's, this all are your string only. And the empty string means which is nothing accepted, is represented as a epsilon. This is the important thing you keep in mind. If empty string as a represented as a epsilon. So another thing is, what is language? What is language? Language is a set of string over the alphabet. Language is set of string over an alphabets. Means like this machine I have designed. This machine is what accepting even number of A. So whatever the input I can give A, 2a, 3a, या 4a या 6a. These all are string only. But language is that which this machine is designed for. Thus here this machine is designing for the even number of a's. So language will be either epsilon. Epsilon means nothing. Nothing means 0. 0 is also should be accepted because 0 is also even number. Here 2a should be accepted. 4a should be accepted. This all is called as your language. Apart from everything, all is the collection of alphabet is called as string is fine. But this machine is designed for the even number of a's. So even number of all the inputs is called as your language. So this is the basic point you have to remember. And after that, some special symbols you have to use in the symbols. Like consider you given state Q0 with a circle. A circle is used to represent the state. This circle is represent the state. Circle with arrow mark. Q0 is the name. Circle with the arrow mark is represented as a start state. Circle with double circle means this is given with double circle represent two circle represent as a final state. And another state if given like this is Q0 and Q1 is going to be after the A. This is called as a transitions. Transition represents a delta, and if you give Q0 to A, it's going to the Q1. You can read like that here. Q0 is the this is input, this is the state, and if I giving the A is the input, is going to the Q1. This is called as transition. This is called as transitions. So this is the basic symbols you have to keep in mind before the starting this course. So now type of finite machines. Yeah, type of automata machines. There are three types. First one is called as DFSM, deterministic finite state machine. This is NDFSM, non-deterministic. Finite state machine. And another is called as NDFSM with epsilon moves, non-deterministic finite state machine with epsilon moves. This is we study in the module 2. This is there in the module 1. So we will discuss in module 1 only about the DFSM and NDFSMs. So what is DFSM is? DFSM, deterministic finite state machine, is having 5 tuples. Must this machine represent as a M having the 5 tuples Q, sigma, delta, Q0 and QF. This is Q is stand for state. Yeah, number of state. What are the state you are using in this to design this machine is represented as a Q. Sigma is represented as a input. Delta is your transition. Q0 is the start state. And QF is the final state. This having the 5 tuples. And this name indicate D means stand for deterministic. F stands for finite, S means state, and A means machine. So what is this machine is doing is converting infinite inputs to the finite machines. You have finite inputs. Like you can consider if I am trying to design any machines which accept any number of A's. Any number of A's. Any number of A's may be 0 A's, 1A, 2A, 3A, Yeah, up to the 1000 crore, any is. So this input is what? Infinite. Maybe 1000, 1 crore, 2 crore, 100 crore also is a input. This is the infinite set of inputs. Now you are converting by this automata, this machine, to convert it in the finite forms. So we will see one by one to discuss about this machine. So all these problems, whatever there in the VTU syllabus, we are divided in the module wise, type wise. So we can remember this type wise, then it will cover almost all the problems. I'm not telling everything, but almost every problems based on this type, it will come in the examinations. Like type 1, I am going to discuss design the DFA, DFSM to accept any number of A. Design the DFSM to accept any number of S. Summation input is given here A star. Star means 0 or more occurrence. You can take any number of A. So first to write the language, what this machine can accept. This machine can accept epsilon, because any number of A's also included 0, and 0 is represented as a epsilon. Epsilon means null string. Maybe can accept 1 A's, 2 A's, 3 A's, so on, 1000 A's. So we'll start with the start state Q0, because this is the start, this arrow marks represent as a start state. And if I'm giving nothing input, this is the all languages which this machine should be accepted. So this, if I'm not giving nothing input, then also this machine should be accepted. So I will write it, this is the also only the final state. This machine only to the final state. Then A should be also accepted, 2 also should be accepted, 3 also should be accepted. Here only I will make it loop A, and it's going to be accept anything. Like consider if I giving 1000 A's, 1A, 2, 3, 4, 5 up to the 100, everything should be accepted. This is the type 1 first problems. Another we'll see second problems. Design the DFA to accept the strings containing even number of S. And summation is given only A. Any even number of S. So language you can define as even number of M is 0. 0 also accepted. 0 is also even number. So we can write epsilon is a even, because epsilon means null string. Maybe can 2, 4, 6 all should be accepted. So here we'll start with the Q0. If nothing is there, then also should be accepted. Means this should be the only the final state. This only should be the final state. If 1 is there, it is not a final state. So 1 you have to write in another state Q1. Then again 2, it should be final state. Q again come back, and this is the final state. This is the DFA for even number of S. Consider if you're giving 6A, so you start with this one 1A, 2, 3, 4, 5 and 6 is accepted. If you're giving 5S, it should be not accepted, because this machine is designed for even number of S. And if you're giving the odd number of A, it should be not accepted. So if you're giving 1, 2, 3, 4 and 5, 5 is not accepted. This means this machine is only accepting even number of S. Similarly, if given the questions type 3, in type 1 only, third questions, design the DFA to accept odd number of S. So language you can write it here A. Here epsilon won't come, because epsilon means 0. Nothing, null string. Null should be not accepted, because this is odd. Odd